Greetings, students. In this segment, we are going to discuss a question on analytical geometry. I have question 3 from the May-June question paper 2019. It reads, in the diagram ABC with coordinates 2, -3 and D, -2, -5 are vertices of a trapezium with AB parallel to DC. E is -2, 0 is coordinates, is the x-intercept of AB. The inclination of AB is alpha. K lies on the y-axis and KBE is angle KBE is equal to theta. So I extracted this question from the question paper. So we've got our trapezium ABCD and the coordinates given. Alpha is that angle and KBE is theta. So we have these questions which we must answer. We are asked to determine 3.1.1, the midpoint of EC, the gradient of DC, the equation of AB in the form y is equal to mx plus c, the size of theta, to prove that AB is perpendicular to BC. We also have the points E, B, and C. So we are given E, B, C are the points that lie on the circumference of a circle. Then we are required to determine the center of the circle and the equation of the circle in the form x minus a squared plus y minus b squared equals r squared. So 18 marks. So this is a question that we must answer. So given, I don't want to get into this question right now. So what I'll do, I'll give you the basics of what is analytical geometry so that you've got an understanding of what we are talking about in analytical geometry. So I have two definitions here of analytical geometry. The first one says analytical geometry is the study of geometric properties by means of algebraic operations upon symbols defined in terms of coordinate system. And analytical geometry is also called the coordinate geometry. So the word geometric or geometry is a branch of mathematics that deals with the deduction of the properties, measurement, and the relationship of points, lines, angles, and figures in space. So it is a branch of maths that it deals with the properties and the measurements and the relationship of points. So we'll be talking about points, especially in relation to the coordinate geometry. I'll come to that one, which is the coordinate system, and also it's the deduction of lines, angles, and figures that are in space. There's a second definition here, is the study of geometric properties and relationships between points, lines, and angles in the Cartesian plane. So what we see from these definitions, we find that our analytical geometry is related to the coordinate system. When we talk about the coordinate system, this is a method of basically identifying the location of a point on the Earth. So it's a method that is involved with identifying the location or the position of a point on the Earth. So the basic structure of the coordinate system is using what we call the Cartesian plane. So the Cartesian plane was derived by one of the mathematicians, René Descartes, and he improvised a way of allocating the position of a point using what is called the coordinate system. So in the Cartesian plane, we have got the x-axis, the y-axis. They intersect there on the origin. Most of us, we might be aware of that one, familiar with this. So this is a Cartesian plane. So we have points A and B, point A and point B, and I've decided to join these 2 points with a straight line here. So the position of a point is indicated by what are called coordinates. So the x coordinate and the y coordinate. So, and B also has got the coordinates, x coordinate and y coordinate. Here I've got x1, y1, indicating that I'm taking point A as my first point, and I've got x2, y2. I'm taking B as my second point. So we indicate the position of these points on this plane surface. So that's what a Cartesian plane is about. We will be using this system extensively in this topic. So in analytical geometry, in this chapter, we will deal with the following concepts. One, we have the average gradient, which means the gradient of a straight line, and the distance formula, which basically relates to the distance between 2 points on a Cartesian plane. And we have the midpoint formula, the angle of inclination and the gradient. We also have Pythagoras theorem. It is also used extensively in this formula, in this topic. We have also the equation of a circle. At a later stage, we will be talking about equation of a circle and the equation of a straight line. Also, we will talk about the equation of a horizontal line, the equation of a vertical line, and the gradients of perpendicular and parallel lines, as well as the intersection of circles. So these concepts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 are very key to understand in analytical geometry. So basically that's what we will be getting into. To know most of the questions, they will basically ask you to calculate or to determine the gradient, the distance. As you can see in this question here, in the question paper, we have got 3.1, which reads determine the midpoint of EC. So we've got the E to C. So what is the midpoint of the point in the middle of those two coordinates? We also have the gradient. So this is the average gradient. Midpoint, we are going to use the midpoint formula. We are required to determine the equation of AB. So this is the equation of a straight line, which we have here. We are required to calculate the size of theta. So this also involves the angle of inclination. So it's very important to know these concepts, and we are going to explain them in this topic. So take this page away. So what we are going to start on is looking at the summary of the formulae that we have that are used in analytical geometry. You'll find this one on page 207 of Kevin Smith textbook, the Maths Handbook, page 207. So that's where you find this formula summarized. So I will start by looking at the average gradient. What is the average gradient, and what is the formula that we use for calculating the average gradient? So the word gradient basically refers to the slope of a line. So what I have here is a Cartesian plane, the x-axis, the y-axis, and I've got 2 points, and I've just given the general coordinates x1, y1, x2, y2. I'm taking A as my first point, B is my second point. So we are going to find the gradient, the slope of this line joining these 2 points. So we are going to use the coordinates of A and B to find the slope of the line. The formula that we use is the average gradient passing through points A and B will be calculated as follows. MAB, M is a symbol, a letter that we use to stand for, to indicate the gradient. So we read this as the gradient of the line AB. So usually we write the name of the line as a subscript here. So the gradient of the line AB, the slope of this line, how do we calculate? This is the formula. We have YB minus YA divided by XB minus XA. So what this basically means is we subtract the y coordinates. We take the y coordinate of B, that's what YB means, general. Subtract the y coordinate of A, okay? And then divide that by the x coordinate of B over the x coordinate of B minus x coordinate of A. So it's YB minus YA over XB minus XA. In general, we write this as Y2 minus Y1 over X2 minus X1. So Y2 minus Y1, and the Y coordinate subtract, divide by X2 minus X1. So that's what we have. As we shall see later, the order does not matter whether we say Y1 minus Y2, as long as we keep the sequence that is 1 minus 2 in terms of Y and 1 minus 2 in terms of X. So what I'm saying is, it doesn't matter which point you take as your first point. Y1, X1 means the first point, the coordinates of the first point. We are taking A as our first point, B is our second point. So we take the second point minus the first point. But we can also work it as the first point minus the second point. I will explain that one in a little while. So the formula that we use to calculate the gradient of a straight line is this y2 minus y1 over x2 minus x1. We are going to look at an example based on that. So I've taken my x coordinate, my Cartesian plane, x and y, and now I've given specific coordinates for point A and point B. So A has got coordinates -4, -1, and B has coordinates -2, -5. So grasp these two coordinates. I'll be using these same coordinates in the future examples that we are going to work with. So let's say A has got these coordinates and B has these coordinates. Now, how do we use these coordinates to find the equation of this straight line? That's what we want to find. Sorry, how do we find the gradient of that straight line? So we use the gradient of the straight line. M stands for the gradient of AB. The slope of this line joining the 2 points is equal to y2 minus y1 over x2 minus x1. So substituting these points into the formula means that y2, if I take B as my second point, so my y2 is the y coordinate of B, so it's 5 subtract -1. So I've got 5 subtract -1. So this subtraction is for the formula, and the -1 is for the y coordinate. So most students, they miss that part. So you must be careful. You've got the double negatives. And then this is the subtraction for the y coordinates, and then the x coordinates is 2 subtract -4. So 2 subtract this coordinate. So it's y2 minus y1 divided by 2 subtract that. So when we evaluate this, add them up, 5 minus -1, that will be a 5 plus 1, which is a 6. And a 2 minus -4, that is a 2 plus 4, which gives us a 6. So eventually, our gradient, our number is going to be 6 over 6, which is give us a 1. So the gradient of a straight line is a number. It can be any number, decimal, whole number, fraction, whatever your number we have, an integer or a decimal number. So it doesn't have any units, so it's just a number that indicates the slope of a line. Now, coming back to this one, sometimes we, as I mentioned earlier, that the gradient of AB, we can also use the formula gradient of AB is equal to y1 minus y2 divided by x1 minus x2. You see there's a slight difference here. It's y2 minus y1. It's 2 minus 1, 2 minus 1. But here we have 1 minus 2, 1 minus 2. So I'm trying to explain that the order in which you name your points is insignificant. So you can call A as your first point, second point, or vice versa. So let's say we are going to work the same problem, but now I'm using 1 minus 2. So how much do we get? So my y1 will be a -1, using the same example, subtract y2, I'm taking B as my second point this time, so that will be 5. Divide that by -4, that is my x1 first point, minus x coordinate the second point, minus 2. So what we will get here is a -6 over -6. This is -5, -5, -4, -2, -6. So this will simplify to 1. The negatives will divide. So which means the gradient of AB will be equal to 1. So you will see that the only difference is in the signs here. Here we've got positives, here we've got negatives, because we swapped the points in our naming. So that's the gradient of this straight line. So to summarize this, we are simply saying when you are asked to find the gradient of a straight line, you need, and you are given 2 points, you need to use this formula, y2 minus y1 x2 minus x1. Substitute the coordinates, then you get your number. It can be any number that you get, maybe 3/4, 7/10, 0.5, any number that you can get, depending on the type of question that you are given. So that's an example that we can take for now on how you can calculate the gradient of a straight line. Okay, let's move on to another concept, another important concept, which is the distance formula. The distance formula is used to calculate the distance between 2 points on a Cartesian plane. So I've taken point A is with general coordinates x1, y1, and B with those coordinates x2, y2. So the question is, how far is it from A to B? Okay, what is the distance between A and B? So that is the question. So we use a distance formula. I will not get into the details of where this comes from, but it comes from the Pythagoras theorem. But I will just give it to you here that for you to calculate the distance from A to B, we use the formula which is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared, which basically means subtract the x coordinates and the square that answer, added it to, or subtract the y coordinates and square the result. Also, this can be given as, usually it can also be given as AB squared is equal to x1 minus x2 squared plus y1 minus y2 squared. Okay, which means we're just trying to get rid of the square root sign by square both sides. If we square both this side, the right hand side, we get this result. When we square this side, we get AB squared. So we can use the distance formula in this format or in that format. I prefer this format because I've noticed that most students, they tend to forget to find the square root, because if you are asked to calculate the distance from A to B, in the end you must always take the square root. So it's better to use the first format, and then you can punch the results in your calculator. So I'm going to take an example based on this, the distance formula. I'll stick to the first example that I've used, the same one, which is -4, -1. I'm going to give specific values to my x and y and see what is the distance between A and B. I'll use the same points that I used earlier in this one, -1, when we were calculating gradient, -1, -5, 2 and 5. So I'll use those points. So on B we've got 2, 5. So the question is, suppose you are given 2 points with known coordinates. So how do we use these points to find the distance between A and B? Okay, so using the formula A, B, the distance from A to B is equal to the square root of, I'll write the equation again, x2 squared plus y1 minus y2 squared. So substituting this means we have x1 minus x2, using the first coordinate here, the -4, subtracting the 2. The result, we must square it, plus the y1, -1, subtract 5. The result, we square it. Now when we simplify this, -4, -2, that is a -6. When you square it, that gives us a 36, and this as well gives us a 36. So in the end, we are going to get the square root of 36 plus 36, which is 72. Sometimes the question may specifically state that you must leave your answer in said form. So this is a said form. In said form, which means you leave your answer with a square root. If you want to simplify it, some questions will specifically say that leave your answer in simplified said form. This one is not simplified. So all you need to do, you can use your calculator. You can use your calculator here. Just type in your square root sign, 72. So square root of 72. When you press, most of you you use Casio. I'm using Sharp, but basically the functions are the same. When you press answer, you'll find it simplifies to 6 root 2, which is equal to 6 root 2. I hope you understand where this answer comes from the topic on exponents and sets, how you can split the 72 simplified to get 6 root 2. So this one is now the simplified form of the equation. But you can also write the same answer as a decimal. So I need to change that one to a decimal. I will get 8,485, which you can simplify to 8.49 units. This is to 2 decimal places. Remember, if the degree of accuracy, the number of decimal places is not specified in your answer, you are required to leave your answer to correct to 2 decimal places. So what does this mean? It means that our distance from A to B is 8,49 units. The units are general, maybe if they are meters, kilometers, centimeters, but the distance is 8,49 units. So that's how we use the distance formula. Okay, so this is an example from the distance formula. Let's get to another concept, which is the midpoint formula. The midpoint formula, this is relates to finding the coordinates of a point that is in the middle of 2 given points. So I have my points here, A, B again. So the question is, what are the coordinates of the point that is in the middle, in the center, halfway between A and B? That is the midpoint. So we need to find the coordinates of that. Usually it's given a general name as M. Okay, I'm just pointing somewhere there, somewhere in the middle, but we don't know the exact coordinates of that point in the middle. So that is the midpoint. So the coordinates of the midpoint of any line segment, this is the formula that we use when you want to find the coordinates of the point. So M is the name of the midpoint. It can be any point P, but we use M as the general name for the midpoint. So to find the coordinates of the midpoint, we add the x coordinates. We divide by 2x1 plus x2 over 2, and then y1 plus y2 over 2. So find the average of these two, and then you get your the midpoint for the x coordinates, and then y1 plus y2 divided by 2. let's get into an example, specific example based on this. I'll use the same example of point -1 and -4, -1, the coordinate that I used earlier. And let's say our B is the coordinates 2, 5. So these are the coordinates. How do I use these coordinates to find the midpoint? So using the example, we're gonna say, I'll write the equation formula again, x1 plus x2 over 2 and y1 plus y2 over 2. So substituting this, my x1, add the x coordinates. So the x coordinate of A plus the x coordinate of B, this gives me -4 plus 2. This we divide by 2. And then -1 added to 5. This divided by 2. So which means my coordinates for the midpoint are -4 plus 2, that's a -2 plus 2, -1. And this is a -1 plus 5, that's a 4 divided by 2, we get a 2. So this tells us that the midpoint of these two, of A and B, has got coordinates -1, 2. So it's somewhere there, -1, and maybe 2 steps up. So it will be somewhere here. So we are able to evaluate the exact coordinates of the midpoint of a line segment using this formula. So whenever a question is asking you to calculate the midpoint of 2 given points, remember that formula. Most of these formula that we are mentioning here, they are given in the formula sheet for your maths exam question paper. So that's the midpoint. Let's put this page aside. We move to the next concept. So the next concept is the angle of inclination and gradient. So the angle of inclination is often denoted as theta. Theta, we spell it that way, it's a Greek letter. We've got many Greek letters that we use for unknown angles: theta, beta, alpha, phi, delta, and so on. So these are some of the most common Greek letters that we use for unknown angles. So this is theta, spelled that way, beta, and alpha. So what we have here is the angle of inclination. I've got a straight line here, and inclination is a gradient or a slope. So this line is sloping towards the x-axis. So what is this angle here? What is that angle? An angle is basically the space between two intersecting lines or surfaces. So there's this line and then there's x. What is this space? Usually measured in degrees. So how much is that space? So we don't know it, so we just call it theta. So this question, this concept is for us to find how much is that angle in degrees. So this is important to note. The gradient of a line is equal to the tangent of the angle of inclination, which is our theta. Now we have got a concept here, tangent. Might have met it also in trigonometry. We are going to do much in it in trigonometry, but I will just put it aside now. A tangent is basically a ratio, a comparison of two sides of a right angle triangle. So I take this one here, and we all know that we have got a right angle triangle, right angle triangle here. Okay, so the right angle triangle. If you recall, if I call this angle theta, and this angle is called the opposite side, opposite the given angle, and this is the adjacent side, and this one is the hypotenuse, right? hypotenuse. So tangent is just a ratio that is given to compare how much is this side over that side. So the ratio, the proportion of this side to this ratio is what we call the tangent. If you recall this one, you are looking at more like a gradient, because we are looking at the difference in the vertical distance divided by the difference in the horizontal distance. So the gradient of a straight line, the vertical distance over the horizontal distance, is equal to the tangent opposite of adjacent. We will not get into the details. But what we are saying is the gradient of a line, which we call M, as we mentioned earlier, is equal to the tangent of a line, the ratio of that line, tangent. And we know the gradient is calculated as y2 minus y1 over x2 minus x1, as we mentioned earlier. So in short, we are saying that the tangent of an angle theta is equal to the gradient. So how do we use this concept? So I will use that concept, this concept. Let's say I've got those 2 points. I'll go back to our point in -4, -1, and I'll take my other point here, B, which is 2, 5. Okay, I'm using the same coordinates we used earlier. So suppose we are given these coordinates. Now, how do I use these coordinates to determine the angle of inclination, how much this line is sloping towards the positive x-axis, the space between these two lines? Okay, so remember, this angle is always between 0 and 180. So at a later stage, we'll look at the angles from 0 to 90, which is acute angles, and then we've got obtuse angles, but we'll come to that at a later stage. So what we are saying is, let us use these coordinates to find the angle here. So using this formula, tan theta is equal to m. Now, what does m mean? The gradient. And how do we find the gradient? We can calculate the gradient using these two coordinates. We have done that earlier. So the gradient is y1 minus y2, so it is 5 minus -1 over 2 minus -4, which we have calculated already to give us a 1. 6 over 6, which is a 1. So the tangent of the angle, is equal to 1. So now, how do we use this gradient 1, to calculate the angle between this straight line and the x-axis? So we use what is called the arctan. Our theta is calculated as arctan 1. What this simply means is, when my gradient is 1, so what is the angle whose gradient is 1? Okay, so whose tangent is 1? So arctan, that's what it means. We spell this as arctan. Is the inverse of a tan. So theta is equal to arctan 1. We use this from a calculator. From a calculator, we press it. I've got my tan here, and I've got my arctan there. So it's yellow. So every yellow function, we access it after pressing the shift key, or second function, on my calculator. So I'll press shift tan. That's what we have. So you'll see my arctan there, and then my gradient is 1. So I want to use my gradient 1 to find the angle. So arctan 1, answer, I'll get 45. So which means my angle will be 45, and it is in degrees. It is in degrees. So that's what we have. When you are working with the degrees, we'll emphasize this one in trigonometry. You must make sure that your calculator is showing a degrees sign here function. Okay, there's a DEG over here, show that it is in degrees, because sometimes we have got radians where there's an R or gradients. So make sure that there's a DEG standing for degrees. So that's what we have. So meaning that the gradient of this line, the slope of this line, the angle of inclination is 45 degrees. So it's sloping at 45 degrees here. So that's how we calculate the angle of inclination. Right, let's move to the next point, which is the equation of a straight line. Very important concept that we need to know in the exam. So y is equal to mx plus c is the general form of the equation of a straight line, or it can be given as y minus y1 is equal to mx minus x1. So I've drawn the x-axis, the y-axis here. Let's say I've got my points. I'm going to use the same points, -4, -1, and b, 2, 5. Okay, so the question is, what is the equation of that straight line? What is the equation of that straight line? The equation of a straight line is in the form y is equal to mx plus c. M, as we remember, is our gradient. X and y are variables. These are the values that we input x and we output y. So they must always appear in my equation. C is a number. We define this as the y-intercept. The y-intercept is always the value of the y value where your graph crosses the y-axis, the y-intercept. We call this the gradient intercept form of the equation of a straight line, because it shows us the gradient in the y-intercept. So m and c are general numbers which we are going to find. We know m is the gradient, c is the y-intercept. So given these coordinates, how do I find the equation of the straight line? Let me emphasize this, that for you to find the equation of a straight line, you need two things. Let me write down here. To determine the equation of a straight line, you need two things. A, you need the gradient, which is m, of the line, the straight line. And secondly, you need 1 point on the straight line. Whenever a question is asking you to determine the equation of a straight line, ask yourself these two things. Do I know the gradient of the straight line? Do I know the slope of that line? And secondly, do I know any 1 point on the straight line? If you don't have an answer to one of those ones, so you must work out how to find the gradient and how to find 1 point. So in this case, we have got 1 point. We have got 2 points on a straight line, A and B. So we can use any 1 point. And the gradient of the straight line, are we given the gradient of the straight line? Yes, we can calculate it as we have calculated earlier. We can use these 2 points to find the gradient of straight line. So indirectly, we are given the gradient of the straight line, which we need to calculate. Then we have our point. So we will see how are we going to use these two. So let's take an example now based on this. So using our first equation, which is y is equal to mx plus c. I'm going to use the first situation. So do I know the gradient first? So let's find the gradient of this line, because that's what we need first. Okay, so we know the gradient of a straight line is y2 minus y1 over x2 minus x1. We have done this one, which is 5 subtract negative 1 over 2 subtract negative 4. We have calculated that one as a 1. Okay, we've calculated this. So our gradient is 1. So we can tick here. We know the gradient is 1. So now, what else is left? Do we have a point? Yes, we've got any point. We can use 2, 5. We can use this one. So let's take a new page here. So we have y equals mx plus c. So now we now found our gradient is 1, and our point, we're going to take point B with coordinates 2, 5. So right, so we calculate our gradient here, and our coordinates of B with coordinates 2, 5. So that's what we are going to use to find the equation of a straight line. So how do we use these two? So we substitute here x and y. These coordinates, they are giving us the x value and the y value. Okay, so this y is represented by the 5 in your B coordinate, and then your x is represented by that, and our m is a 1, we know. So what we basically have is a 5 equals our m is 1 multiplied by 2 plus the c. So this will give us 5 is equal to 2 plus c, and our c is 3. Okay, we solve that equation out. So which means therefore the equation of the straight line, now we have to rewrite this, putting in the value for x, for m and c. So our m is 1 times x plus our c is 3. Okay, so this simplifies to y is equal to x plus 3. So that's the equation for a straight line. Always you must have your x and y, your variables, showing in the equation of the straight line. Okay, now let's say we are using the format y minus y1 is equal to m x minus x1. The second format. Remember, we said that the equation of a straight line, has got 2 formats. It comes in 2 formats, this or that. Is a matter of your choice. Which one do you want to use? Actually, this one is my favorite. Y minus y1 is equal to m. So y minus y1 is equal to m x minus x1. So in this case, we have calculated already the gradient. We're going to get the 1, and our point, I'm going to use the same point B with coordinates 2, 5. So how are we going to calculate the equation of the straight line? So in this case, in this equation here, your y1 and x1, these are representing your coordinates, your point, the point that you're going to pick. So in this case, my 2 will be x1 and my 5 will be y1. So remember that the y1 and the x1 are the coordinates of the point that you have picked up. Okay, and your x and y are the variables that you remain with in your equation, and your m is the gradient, meaning that substituting this is going to give us y minus the y coordinate of your point, y minus 5, will be equal to gradient is 1 into x minus, where x1 is a 2. Okay, so y minus y1 equals m times x minus x1. So y1 and y2 are the coordinates of your point. So simplifying this, we will get y minus 5 is equal to that one, x minus 2, and then take the negative 5 over, we're gonna get x minus 2 comes over, it becomes a positive 5, so we will get y is equal to x plus 3. So it doesn't matter which method you use, which formula you use, this or that, you will eventually come to the same answer. So meaning that just by knowing the coordinates of this point and that point, we know the